Okay, just a moment. Okay, so today we are going to chapter 6, arrays. Array, so in this chapter you need to know how to create an array, okay? And also first at the beginning, so we will use the one-dimensional array. Then the later, so we will learn how to use the two-dimensional array. So array is this one. So it's a date structure. So consisting of the related data items of the same type. This is important. So array, in an array, the elements, all elements are in the same type. So this means if an integer array, so all elements are integers, integer numbers. If the string, so all elements are characters. Okay. Then in chapter 10, so struct. So this is another data structure. This one could have different types for its elements. Okay. Array and the structures are static entities. Yeah, we said before. So static, so this means this one will stay in the memory. Okay. Array, so is a group. So an array is a group of the contiguous memory locations that all have the same type. So this means for array, the code will save array's elements one by one in the memory. So one by one. Okay. To use the elements in an array, so we need to use array's name. So array's name and the position numbers for that element. Position numbers we also called this is the index or index number. Okay, so just go to the next. So this is example of the array. So name is C, so very simple. So name is the C. Here, this one, so you can see index number start from 0, 0, 1, 2, until 11. Okay, so totally it has 12 elements. Okay, this array. So array C. So for each element, so C0, so the value, so it's minus 45. C1, 6, C2, 0. So every element has its own value. Okay. And you can see their type, data type are the same. So these are, the array is an integer array. So all elements are integer numbers. And for index number, so we need to use square rules. So square brackets include index numbers. For C language, so index number starts from 0. So this is important. So for C language, index starts from 0. Other language, maybe index number start from 1. Okay, so the first element in every array is the zeroth element. So index number start from 0. Okay, this is important in C. Okay. Array name. So array name, we could just create array name like other identifiers. We know, so just for letters, digits, and underscores. And the first character could not be digit, cannot be allowed. Position number, so we said before, so it's just index, okay, or subscript. Index number, so should be integer or an integer expression. So we know, just like example, so 0, 1, 2, 3 until their indexes are the whole numbers or integers. Okay, so this example, so index, so is integer expression. So A is 5, B is 6. So for index, so it's A plus B. So we know result is still is an index, right? So that's the 11. So index the array name, so it's L value, L for left. Okay, so this usually left side of the assignment. Okay, so for that one, so name, array's name is just the C. Again, so name just you could use letters, numbers, and underscore, but first character should not be a number. Then for elements, so we use the index numbers. Name with the index number with the square brackets. This is the square brackets. In other language, maybe use the parentheses. Okay. So C0, C1, C2, C10 until C11. So again, index number start from 0. And so the value for AV elements, so let's show, so just for example, C0 is minus 45, C1, so it's 6, like this. So for elements, so you can just use elements as the integer numbers. So here, just like this. So printf %d we know is for integer, right? The C0 plus C1 plus C2. So this just add the first 3 elements together. And we can also do other mathematical operations. So x equals C7 over 2. So for this one, so we know this is actually is an integer division. Okay, so square brackets, so that's for the index. Okay. So this is now we have a new one here. So square brackets. So now this has the highest order. Define array. Okay, so this is example just like the former one. So now we confirm this is an integer array. So int c 12. Okay, so 12. So this means array C has the 12 elements. Okay. And for this one, so this is for more. So int integer. So b 100 x 27. Okay. So both arrays are integer arrays. Okay. So array B has the 100 integers. Array X has the 27 integer elements. Again, so just remember index start from 0, 0, 0. String actually is just a character array. Okay, so this is a special array. We will talk about this later. Okay, so this one just show define array first, then initialize the array. So for array, we know usually array has the many elements. So how to assign values to AV elements? So we have one way solution. So this one. Okay, so this is the same. So standard input and output identifier, library identifier. So main body, so output is int, and input, so argument is word. Then int n5. So this 5 elements, right? So and this is also is an integer. All elements are integers. Then here just use for loop, so initialize the elements. For size t, I equals 0, I less than 5 plus I. So this means the loop will run 5 times, right? Start from 0 until 4. So 0, 1, 2, 3, 4. So totally 5 times. Then in the body, so we just do assignment. So n I equals 0. So I start from 0. You know, I actually is the index of the array n, right? Start from 0, then until 4. So every element in array n now is 0 after this 4. Then printf, so this is print out the message. Then %s, this for first keyword. So here element. So this has the 5 correct. No, totally let me check. So 1, 2, 3, 4, 7 correct. So %s, so this one, so we'll get the 7 spaces for the first node. Then %13s, we said this before. So this is for the second word. This word, so just value, so just have the 5 characters. But so this one 13. So totally this word will occupy the 13 spaces. So this means 13 minus 5, so we have the 8 white spaces, and this is the right element. So every word start from the right position. Then use the for loop again, just print out the elements. So for size t, I equals 0, start from 0, I less than 5, so 2, 4, plus I, so every time I just edit. And here, so printf %7 u, for here %7, this is because here I just count this. So element, this word has the 7 letters, 7 characters. So here we use the 7. Then %13d, this one, so this for the second argument here. So ni, so this is the element. \n, so we know this for u1. Here we have the warning, right? So this symbol has the warning, this because the he. When definition I, we use the size t. Size t, actually in the modern C language, this is for L, so long, unsigned, long integer. Here I use the U here, U is for unsigned integer, so we get a warning. So because data type are not matched. So you can see the error is for I. For unsigned int, but the argument has the type size t, that's for unsigned long int. So if we just remove the warning, so we need to change this to L. So you can see the warning symbol now is disappeared. So for alt one, so maybe size t is for the unsigned integer. But now I think I'm not sure. Let me just check in the online GDB later. Okay. So let me run this first. So we will get 5 zeros. Why so slow? Okay. So you can see element, so 0, 0, 1, 2, 3, 4. The value are here. So just 5 zeros. So again, so they are right. Okay, just a moment. So let me copy this to the note. Okay, let me go to online GDP. Let me double check online GDP. I think you use the online GDP. So I use the Firefox because I prefer Firefox. Yeah, I can customize this. I use a lot of it on here. Okay, so let me delete this one. So paste our code. Then let me change this to U, back to U. Okay, C. So it's C here. Let me check whether we have others. Just C. Okay, so you didn't mention the version. Okay, just run. I select this. Let me reload. Just reload this one. Okay, so still delete this one. Paste our code. One. Which is build. I used this before, but today don't show picture. Yeah, everything now allowed here. I don't know why. Okay, so let me use something. I think the Zoom use a lot of CPU. Yeah. My laptop is old, almost 10 years old. Let me change this first. Language. See. Okay, so here you can see, oh, it's here. So you can see for, oh, you also recognize this. So I is size t, so now this is the unsigned long integer. So you also need to change this to LU. So should be %7 LU. So for our textbook, maybe a little bit old, yeah. You know, we have the new version, but nobody can get the new version, new edition textbook. Okay, I think now our is the 8th edition, right? 9th edition actually is already public from last year, but nobody can get the hard copy of the. So that's one thing. So we still use the old edition. Okay, so now no warning message. Okay, so for you if you use online GDB, also change this to LU. Size t, that's for unsigned long integer. You also need to change this. Okay, so go back to the. So this shows how to define array and how to assign values to array. So define, just like the normal one, you also need to define the size of the array here. And for assignment, so we just use for get AV element. So this is the one way, okay, to assignment. We have another way, okay, we will show later. So size t, so this is for unsigned integer number, okay. So actually it's not unsigned integer, unsigned long integer, sorry. So for this one, this is in this library, standard definition, okay. STD for standard, DEF for definition. So this for standard definition library. This one is already included by our the standard IO input output library. So we don't need to include this. So for example, if we just include this one, so let me check what happened. Okay, so here, let me put on this one. So we know if I have this one, so this is the, okay, so I just go here, so for this way, actually we include this twice, standard definition header file, because standard input and output header file already includes standard definition. Let me check what happened for this one. Get volume or nothing. Yeah, that's nothing. Okay. So that's okay. If this one we cannot delete because printf is in the standard input output. Okay, just delete this one. Okay, so that one we use the for loop to do the assignment. We can also use this one, use the curly brackets to do assignment. So this is shown here, 6.4. Okay, so standard input output main function. So now definition. So we do definition and initialization at one. So int n5, the same as before, but now we do assignment in this place. So assignment, first we need to use the curly brackets, include values of the assignment, of the elements. So 32, so this is for the first element, comma, this is for separation. Okay. Then second one, 27, comma, 64, comma, third one, 18, fourth, comma, the last one, 95. So this means we do assign values. We did assign value to every elements value. For definition, this is the 5. So n, array n has 5 elements. For assignment, so we have 1, 2, 3, 4, and 5 values. So each element has this value. So this is the full initialization. Then print f. So this is the same as before. %s, %13s, and the element value. Also use the for loop to show elements value. This is the same. So size t, I equals 0, I less than 5, plus I. And for this one, so print f, the same, %7 u. We should change this to lu. Then %17d, this is for the integer percentage. So I index number, ni, so we use the for loop, get the any element. Okay, so you can see in this table, so 0, the first element, so it's 32. Second, so 27, third, 64, fourth, 18, fifth, so 95. Again, index number in C starts from 0, So in this way, so now, I said before, this is the full initialization. So this means every element get a value. Okay, so now if there are fewer initial zeros than elements in the array, then the remaining elements are initialized to 0. So this is important. Just like this example. So for example, let me change a little bit. So for this one, so I just have the 4 values here. Just give me one. So just 3 values. Array has the 5 elements, right? So this means the first 3 elements now have values. Then the last 2, the 4th element and the 5th element, so they are initialized to 0. So now they are initialized to 0. Okay, so let's run this. So you can see 4th and 5th, now they are 0. If we didn't do assignment here, the remaining to be 0. The elements are 0. Then if you want the all elements to be 0, so you can just like this. So int n10 equals curly brackets 0. So all elements equals to 0. And for initialization, we also need to mention for this is the full initialization. Right? If for example, if I miss this one, the first one I didn't do assignment, so this is not correct. So you can see we have error message, class is error message. So this means here we should put a number in this position. So if you want to go to 0 with this, you put 0 here. So you cannot keep this back. So now only for that one in here, so you could do this. So this means remaining the elements are zeros. You cannot put the middle elements to blank. This is important. Okay, so we need to remember arrays are not automatically initialized to 0. Okay, we need to do this manually. So this is actually for this one. If you want all elements to be zeros, so you just need to put 1 0 and with the curly brackets for some. Array elements are initialized before program start for static array and also at runtime for automatic array. Static we said before, so that's the values. Actually, as elements will keep in the memory for whole 1 minute. Okay, so this is so array size is 5, right? But here 1, 2, 3, 4, 5, 6. So now you have the 6 values. So this is not correct because array n only has the 5 elements. Has only 5 elements. So this will get a syntax. Okay, so for this one, if you do a full initialization, so then the size, so you could keep the array size blank. So you don't need to mention the size here. Then the compiler will get the size automatically. So just count values here. So 1, 2, 3, 4, 5. So then the compiler knows array n has the 5 elements. Okay, so this is 6.5. Oh, this is with symbolic constant. Okay, so the new things here, this is this one, symbolic constant. Symbolic constant, so sharp, simple, define, then size 5. Symbolic constant, so this means actually the word size, this one is just the number 5. So size is the number 5. Okay. Usually for a constant, we always use capital letters. So this means this is constant. Then in the main body, okay, so int s size. So here the size is not a number, right? So this is the symbolic constant. When the compare this line, then he will just replace size with the number 5. So just replace size with number 5. So size is number 5. Okay. So this means the array S, so now it has the 5 elements. Right. Then in the for loop, so size t, j equals 0, j less than size plus j. So j now is from 0 until 4, right? 0, 1, 2, 3, 4. Then size j, so equals 2 plus 2 times j. Okay, 2 times j. So this gives the assignment. So at the beginning, j is 0, so this is the 2. S0, so it's 2. Then S1 is 2 plus 2 times 1, so that's the 4. Like this. Okay. So in this for loop, so we do the assignment for every element in array S. Then printf, almost the same. So %s, %13, s, \n, element, and right. Then use for loop, get this everything. So size t, j equals 0, j less than size plus j. Then just print f %7u %13d \n j s j. So just get the element out. So this is the same size t. So now this one is the unsigned long integer. So we will change it to LU. Then let me so element, so now from 0 to 4, right? And for elements I value, so it's from 2, 4, 6, 8, 10. So here the new thing is just the symbolic constant. We define symbolic constant here. This is because we can just change these numbers. For example, change this to 9. Then array S, now size is just the 9. So we don't need to change others. So let me run this. So you can see array size now is 9. So when we define a symbolic constant here and use this symbolic constant as the size number of the array, when we try to change the size of the array, so we just change the number here. So this is very convenient. So this is for constant, symbolic constant. We keep changing. Yeah, just keep this error message. Just a moment, let me go to others. So symbolic constant, so here, symbolic constant. So we said before, so when we define like this, so this actually is just do replacement. So when compare with this constant, so just replace size with the number. So this is the same. So we can change this to 1000 elements. Just need to change the size to 1000. This is very easy. For definition, you need this is very important here. Don't put semicolon. Oops, this one. So don't put semicolon at the end of this now. So this will get an error because symbolic constant will do the replacement, right? Then the size here, when compare with the size in the main body, we just replace size with the 5 and the semicolon. So this means S inside square brackets, so 5 semicolon. So this is not correct, right? So size here should be an integer number. Just remember when we define a symbolic constant, so we will replace that the constant with the anything for here, with anything here. So just delete the This is, I said before, for constant name, always use the uppercase letters. Always use capital letters. Then we know this variable is the constant. Okay, so in multi-word symbolic constant name, so separate the words with the underscore for the readability. Okay, so now this is still summation. Okay, so now this symbolic constant, so size is the 12. So array should have the 12 elements. One body, then A size, so 12. So this is 12. So 1, 3, 5, 4, 7, 2, 99, 16, 45, 7, 67, 89, 45. Let me check how many of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the full initialization. So every element has 5. So int total equals 0. This is the sum. So at the beginning, so just assign total to 0. Then with for loop, do the summation. For size t, I equals 0, I less than size plus I. Then total, so plus equal AI. So for this one, so we know actually this is, let me type here. So this is actually is total equals total plus AI. Right. So plus equal actually equals this. So total equals total plus AI. But at the beginning, I is 0, right? So this total at the beginning is also 0. That's the 0 plus A0, that's the 1. So 0 plus 1 is the 1. Then assign back to the total. The total now is the 1. Next time for I is the 1. Then total now is the 1 now. So 1 plus A1, so that's the 3. So 1 plus 3 is 4. So this means after this for loop, so we will add all elements. Then just print after this for loop. So we get the sum of the. Then just print out total of the array element value is %d \n, so total. Let's get total number. So total, so it's just 380. Okay, so no. So this one. So the former actually is this one. Okay, so figure 6.7. So this one is for summarize survey result. So for this one, so 40 students were asked to rate the quality of the food in the student cafeteria. And on a scale of the 1 to 10, 1 means poor or awful, and 10 means the excellent. So place the 40 responses in an integer array. So this array should have 40 elements. And summarize the result of the pool. So that means how many of the 1, how many of 2, how many of 10. Okay, so let's go to this one. Okay, so now we define the two symbolic constants. So first one, define responses size. So you can see now the constant has the two words, right? So we use the underscore for separation. All words are capital, all correct, all letters are. Then 40, so we now has the 40 responses, right? Then defined frequency size 11. This is because for our the grade is from the 1 to 10, right? 1 to 10, actually this just has 10 numbers, right? And here we define the frequency size is 11. This is because the array is index starts from 0. The grade is from the 1 between the 1 and 10. So this means we don't use the first elements. Just use the remaining 10 elements from the index 1 until index 10. The main body, okay, here. So int frequency array, frequency size. So this is the 40 equals 0. So curly bracket is 0. So this means every element in the frequency array is 0. So this. Then the last one. So frequency array. This is frequency array. So elements, the size is 11. Is here. So this is 11. Then for responses, so this is responses the size. So total has the 40 elements. So should have 40 elements here. The number, the value is between 1 and 10. But totally has the 40 values. Then the last one, so we use the for loop, count the frequencies of every element. So for loop, so size t from here, size t, answer equals 0, answer less than the response's size. So this is the 40 plus answer. So this means we will go through any elements in the array responses. Then for this one, so a little bit complicated. Okay. So first one, let's talk about this. So plus frequency, then is index number, so it's responses, then answer. Okay. So now let me type here. So just get the detail of this one. So at the beginning, answer is 0, right? Let me. This is the step 1. So answer is 0. Answer is 0. So then this place, so answer is 0. Then responses, this array, then index is 0, right? So we go to So we go to the responses 0. Okay. So response 0, so go back to response array. The first element's value is the 1. Right. Then frequencies, so now is index number is the 1. Okay, so so this one, so this means actually now changing is the plus frequency 1. So for this one at the beginning, every element in the frequency array is 0, right? So now we get this value from responses array. So this means frequency second element will be increased by 1. At the beginning is 0, right? 0 plus 1, so it's 1. So frequency, let me type some place. So frequency 1 now is the 1. The value now is the 1. Let's type here. Okay, now it's the 1. So now we finish this step. So go back to the for loop. Plus answer. So now we know the answer should be 1. So now 1. Similarly, first get the responses 1. So response 1, so it's the second value, second element. So it's the 2. Then go to the frequency array. So now it's the frequency array 2. Okay, go to the frequency array 2, then do plus. Yes. I can update the cursor value. Cursor, yeah. And then frequency 2, so now it's at beginning, frequency 2 is also 0, right? Plus, so frequency 2 now is the 1, so we get the 1 value. Keep going, 3, so answer now is 2, right? So actually, so we will go to the third one also. So this is the 2. So response 2, response 2 is third one, so actually now we get 6. Okay. So this means frequencies, so actually it's plus frequency, cannot see very clear. So it's 6 plus this. Then frequency 6 now will be 1. Okay. So just like this, so we will go through every element of the array responses and then count the values and put the result into the frequency array. So here you can see for the frequency, so we don't use the first element. Its index number is 0. So we don't use. We just use the frequency, the elements from the second to the last. So from the index number from the 1 to 10. Actually, the elements from the second elements to the 11th. Okay, so for this one, the key actually is here. So it's this one, the for loop. So after for loop, so we count the AV grade. So print F %s %17s, so the second so 17 spaces. \n u9, so waiting, then frequencies. Okay, so use this for loop. So size t waiting equals 1. So start from 1 because for the frequency we don't use the first element. Next index number is 0, so we don't use this. So just start from 1. Then rating less than frequency size, then plus rating. Then print f. This is the same. So this should be LU for the rating. %17. I forgot it. %6 LU. So this first has the 6 spaces. %17D. The rating, frequency, rating. So get the elements in value. Elements value in frequency. Then, yeah, just this one. So so you can see, so for the grade 1, so just has the 2 results. So 2 of 1, 2 of 2, 2 of 3, 2 of 4, 5 of 5, 11 of the 6, 5 of 7, 7 of 8, 1 of 9, 3 of 10. So this calculator not too bad. Okay, just so okay, you can see, yeah, it's not too bad. That's okay. So the most grade is 6, right? So because this is the mode number statistics. Okay, so for this one, so 2 symbolic constants. Here for frequency, we don't. So we don't use the first elements. So just ignore frequency 0. It's because our grade is from 1 to 10. Yeah, So the key statement in the code actually is this one. So plus frequency responses answer. So answer, so this is the index of the responses array. So move from the 0 to 39. Then for get the value of the responses array element, then use this as the index of the frequency array. Then just do plus, so count numbers. Okay, so I talked about this before. So regardless the number of the responses processed in the survey, so only an 11 element array is required. So we don't use the first one. Let's ignore ignoring element 0 to summarize the So if the date contained invalid values such as 13, but in the for loop we didn't check this, right? So the program will attempt to add 1 to frequency 30, but frequency just has the 12 element. So this will be outside the bounds of the array. So you get some, usually we call this is overflow. So C has no array boundaries checking. So to prevent the program from the referring array to elements that does not exist. So you need to check by yourself. This is the key. So we can do this. Let's check what happened. So for example, let me change this to this. Okay. So we know this is not right result. So the code is still running, but now we get some error message here. So actually for our compare, didn't find issue for this number. But when we run the code, we get some error message. So this is out of the boundary, of the array. So this one will create some bugs in the code. So when you do this, actually the better check the value before you do the assignment. Thus you can just check this one. If this number is less than greater than 1, less than 10, then you can do assignment. That's like this. Okay, so we can just check by ourselves. So for example, so if here so answer greater than or equal to 1, then or so not this one. So this is for all operator. All responses answer less than or equal to 10. Then we can do this, do the assignment. We can do the assignment. This one, so actually we need the so this is just for the if function. So this one now is for if function. So now let me change this to 15. So now we should get the correct result. So without any error message. Still something wrong. Let me check. So this one Let me check whether we compare this. Yes, do something wrong. 15 should not work for this one, so let me check. Here, 1 of 1 is correct, so only 1 of 1 now, so no 14. Yes, this should work. Why not work? Let me check. Okay, so just to make sure, is the analysis include this one. Okay, yeah, without any error. Great, then 1, nice, then 10, then we can do this assignment. Okay, should be correct. Okay, that moment, let me check here. Let me delete this one. Still has this error. So it's so weird. Let me use this. This one for one statement should not use. We could ignore this. Yeah, the same error message. I don't know why. Let me change this to this one. Yeah, this is correct. So no error message. Let me double check. Why this get the error? Here we use the if function, right? Check this one, response answer, great, then 1 or less than 10. Then we can do this statement. 15, so this should be else, right? So let me double check here. So let me check. If this condition is false, so that's the 15. So this one we should print out 15 here, right? So let me check whether we get this. No, so this C function not working. Missed something. So not all function would be AND. Okay, should be AND, not the all. So why good? Why this is get the one, but this now there's no error. Okay, so just the one of one here. But why this is the one? So this should be and, so not the or. Okay, so once the frequency results should be between 1 and 10. So last time I did 1. Then else, so this is the fourth. So we get the answer. Let me check the answer value. Okay, just I think got something wrong here. Let me check the answer. Answer. Oh, this is assigned integer. 10. So let me check. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 0, 0. Then this is the 10. Yeah, this is correct. So answer is 10. Frequency 10. Why just show 1 here? I am confused this. Right? This should get the 15, right? So answer is 10. Why this get the 15? Why get the 1? Okay, so okay, let me check after class. Okay, don't talk about this. So this one should get the 15 out, not the 1. Why? So this is D for dancing for integer. Okay, let me just a moment. Let me change this a little bit. So let's show whether get this the 10 out or not. Always shows 1. Okay, I think it's just print f something. Okay. So yeah. Okay, I will check. I will check this after class. Just keep going. Okay, so now this one. Okay, so now this one, so just keep going to the former, just do a little bit more for the former result, former example. So grabbing array element value with the histograms. Histograms, so this means a larger value, we will get the longer bar, right? So this one. So for the bar here, we will use the star for the bar. So 6.8. So here just a little bit. So for symbolic constant here, so its size is the 5. So size is the 5. And then for the n, array n, so we now have these 5 values: 19, 3, 15, 7, and 11. Okay. Then for table head, so this for table head, percent %s, this for element, percent %13s for value, percent %17s, so this for the histogram. So this is the table head. Then in the for loop, so size t, I equals 0, I less than size plus I, so this will look through the elements in the array n, right? Go through the elements. So print f, percent %u, percent %13d, also some spaces. This is for, actually for this one, 17s here. Okay. Then I, so this is size t, so this should be LU. Let me change to LU. Then the last one, so Ni, so this is the value for the element, right? Then according to the element's value, so we need to print out the stars. So that's the histogram. So for int j equals 1, j less than ni, so current element value. Then plus j, so just print f, percent %c for correct, so just for one correct. So star. So here, if the elements ni, the value maybe is 5, so this for loop will run 5 times, right? Then we'll print out 5 stars on the same line. After this for loop, so puts, so this blank one, so we know this is for new line, just for new line. Okay, so let me run this. So you can see here again, so element, so 0, 1, 2, 3, 4. Then second column, so this for values, okay. 19, 3, 15, 11. Then histogram, so big value, so we get the longer bar. Okay, so this should have the 19 stars here. So let me count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So just the 19. So star number, so just for the element one. So this one will get the element value more clear, because we know histograms will get the clear view for values. Okay, so this is the 8. Okay, this also shows here. Okay, so let me stop here. Before we exit, let me stop record first. Don't go to